question number 3, we're going to look for the relative extrema of f of x equal to 3x to the 5th minus 5x cubed. Let's find the derivative f prime of x, which is 5 times 3, 15, x to the 4th, 5 minus 1, minus 3 times 5, 15, x to the 2nd, 3 minus 1. Now, let's set f prime of x equal to 0 to find the critical numbers. Since the function is polynomial, the derivative function is polynomial, it's everywhere defined, so we only need the zeros. 15x to the 4th minus 15x squared is equal to 0. The greatest common factor is 15x squared, and it's going to be multiplied by x squared minus 1. We'll set each factor equal to 0, 15x squared equal to 0, therefore x must be 0, or x squared minus 1 equal to 0. X plus 1 times x minus 1, difference of two perfect squares, is equal to 0. So x is equal to -1 or x equal to 1 when we solve the two linear equations. So the critical numbers are 0, -1, and 1. We build a table of values: 0, -1, 1. Those three numbers are zeros of the derivative. And we're going to test for sign. Well, we'll test for 2. Notice that the first factor will always be positive. So we'll set up f prime of 2 just to get the sign. First factor is positive, and the second one is 4 minus 1, which is positive. So this is positive. Between 0 and 1, we're going to test for 1/2. And f prime of 1/2. First factor is positive. Always positive because we square it. Second factor is going to be 1/4 minus 1/2 squared is 1/4 minus 1, which will be a negative number. 1 is 4/4. So this is negative. Test for -1/2. If we notice that the function is even, so we know that it's going to be reflexive about the y-axis, which is x equal to 0. The first factor is positive. The second one, 1/4 minus 1, because we square -1/2. So it's going to be negative. And of course, when we test for -2, it's going to be positive. We said it was going to be reflexive about x equal to 0. But let's check it anyway. -2, the first one will be positive. So it's going to be positive. The second one will be -2 squared, which is 4. 4 minus 1 is positive. Notice that the function increases until it reaches 0 and then decreases. So in this interval, -1 is a max. This one, there's no change of sign. And it decreases, goes to 0, and then increases. So 1 is a min. So the correct answer is